What we're going to do is we're going to solve polynomials by factoring. We know we're solving because it's equal to 0. So it's not just factoring. And in this case, we're going to be factoring a quartic. So when we have two terms and we could take the square root of each of the terms, that's the difference of squares. So that right there becomes x squared minus 9 and x squared plus 9. Now, our first binomial is a difference of squares again. So that becomes x minus 3 and x plus 3. Our other one just stays as x squared plus 9. Now, since it doesn't factor, what we're going to do is we're going to solve it. So I'm going to set it equal to 0. So I'm going to subtract the 9, and I get x squared is equal to negative 9. And then I take the square root. And if we remember from the last unit, when you take the square root of a negative, it becomes I. So that would be plus or minus 3i. Now, we have these other two binomials, and in order to find the zeros, we're basically just doing the opposite. So that means that x is equal to a positive 3 and a negative 3, so I'm just going to put plus or minus 3, and then I have the plus or minus 3i. Now, one thing to recognize is that when we have a quartic, we should have 4 answers. And here we have 2 real and we have 2 imaginary answers. Remember, imaginary is a number that has an I with it. So for the second one, what we're going to do is we're first going to notice a GCF. So I'm going to factor out a 5x. After I factor out a 5x, what I'm left with is x squared minus 16 is equal to 0. And then I can, that is not squared. That would be to the 4th. And then I take the square root. And so what I have is the 5x. And then I have the x squared minus 4. And I have the x squared plus 4. So I can factor this one some more. It's a difference of squares again. So I have the 5x. And then what I have is the x minus 2, x plus 2, and then I still have the x squared plus 4. Now I'm going to solve this third binomial just like the last one. I'm going to subtract the 4, so I get x squared is equal to negative 4. I take the square root, and that right there gives me x is equal to plus or minus 2i. And then I'm going to be looking at the opposites. That would be 0. And then these ones, the opposite of negative 2 is 2, and the opposite of positive 2 is negative 2. So that would be plus or minus 2. Notice I have 5 answers, and that's expected because we have degree 5. Now for letter C, this right here is a difference of cubes. So it would be x to the 3rd minus 2 to the 3rd. So my a value is x, my b value is 2. So when I factor it, I get x minus 2, x squared plus 2x plus 4 is equal to 0. Now the problem with this one is that our trinomial does not factor. So what we have to do is we have to use a quadratic formula. If you remember, a is 1, b is 2, c is 4. So we go x equals negative 2 plus or minus the square root. 2 squared minus 4 times 1 times 4 all over 2 times 1. So I'm going to simplify this some more. Negative 2 plus or minus 2 squared is 4. 4 times 1 times 4 is 16. And negative 2 plus or minus, that gives me a negative 12. And negative 12 can simplify into plus or minus 2i square root of 3 over 2. So when we divide it by 2, we're getting negative 1 plus or minus I square root of 3. Now, we also have the opposite, which is the 2. So that means that my other answer is a 2. So we have 3 answers, the 2, the plus, the negative 1 plus I squared root of 3, and the negative 1 minus square root of I over 3, which we could have expected because a cubic should have 3 answers since it's degree 3. Okay, if we're looking at letter D, what we're going to do is we see 2 terms. We see that we could take the square root of each one. And this is going to look a little familiar. So x squared minus 4 and x squared plus 4 is equal to 0. We can factor the first one. That would be x minus 2 and x plus 2 when we take the square root of each of them. And then with the x squared plus 4, what we're going to do is subtract the 4. So we get x squared is equal to negative 4. We take the square root of it. And as we've said before, the square root of a negative is I, so that's plus or minus 2i. Then we're going to look at our 2 real answers. The opposite here would be 2, and the opposite here would be negative 2. So I'm going to put plus or minus 2. Notice 4 answers, and we have degree 4. If we're looking at letter E, first thing I'm going to do is I'm going to factor out a 2x, and then that leaves me x to the 4th minus 625. And I can take the square root of that, and what that gives me is 2x, and then x squared minus 25, and x squared plus 25. I can factor the first binomial some more. So that gives me x minus 5 and x plus 5, because I can take the square root of both of those terms, so it's a difference of squares. And then if I'm looking at my last one, it can't factor, but what we're going to do is we're going to solve it. So I'm going to subtract the 25, and I get x squared is equal to negative 25. When I take the square root, I get plus or minus 5i. So my final answer would be plus or minus 5i. Those are 2 imaginary solutions. Then when I'm going to look at my real solutions, whenever we have a monomial, it's always 0. And then the opposite of negative 5 is 5, and the opposite of positive 5 is negative 5. Now, looking at letter F, I see that they have a 2x in common, so I factor out a 2x, and what's left over is an x cubed plus 27. And I notice that this is a sum of cubes, so I'm going to rewrite it as x cubed plus 3 cubed. And so my a value is x and my b value is 3. So when I rewrite this, I have 2x, and then I have x plus 3. I have x squared minus 3x plus 9, and then is equal to 0. So I'm going to use the quadratic formula. So x is equal to 3 plus or minus the square root. I'm going to take negative 3 squared minus 4 times 1 times 9. And I'm dividing the whole thing by 2 times 1. That gives me 3 plus or minus the square root. Negative 3 squared is 9. 4 times 1 times 9 is 36, all over 2. I have x equals 3 plus or minus the square root. 9 minus 36 is negative 27. And when I simplify negative 27, that is going to give me 3i square root of 3 all over 2. So these are two of my solutions, but I also have a monomial, which gives me an answer of 0. And then I'm going to be looking at my opposite here. So the opposite of 3 is negative 3. So I should have 4 solutions. And since this is a quartic, that works out perfect.